actually where, maybe on this one.
There you go. There's that.
Ah, there's and then
Present. Just click present.
where's present? Oh, yes, present.
There we go.
Cool.
That works. That's awesome. Thank
So you want to say something?
Lily, do you want to start this one? Oh, it's not. You start.
Hello everybody, and welcome to the third workshop of the School of Data Journalism, second edition in Perugia. We're really, really happy to have Gregor Eich with us, and I'm sure that you're probably as excited as we are about it. Just a couple of words about the School of Data Journalism and about how it's organised before we start. We're very grateful to the organisers of the International Journalism Festival for letting us organise it. It's a collaboration between two organisations. My name is Lucy Chambers, and I work for the Open Knowledge Foundation, currently in Berlin. We work both with governments and with kind of civil society organisations like journalists and NGOs. Both to open up access to information and to work with people who need to use that information once it's been put out in the public so that they can use it. And I work particularly on a project called the School of Data, which I think is confusing people a lot because this is a School of Data Journalism. But there are two organisations involved in the School of Data Journalism. The second organisation I will hand over to Liliana to tell you about, but the European Journalism Centre has been our partners in organising this, and Liliana runs the datadrivenjournalism.net website. All of the tutorials and things that you see here, both schoolofdata.org and datadrivenjournalism.net are going to publish straight after the workshops, so don't worry about taking notes all the way through this. You can give Gregor your undivided attention, and he will guide you through the process. But over to Liliana now.
Hello everyone. I'm pleased to see so many of you here today. Data visualization is a very popular topic these days. I am Liliana Bounegru. I lead data journalism activities at the European Journalism Centre. The center has been organizing a lot of training activities in data journalism over the past 2 years. We have a website called datadrivenjournalism.net where you can find learning resources about this topic. We also published a manual last year together with the Open Knowledge Foundation called the Data Journalism Handbook, which is freely available online at datajournalismhandbook.org, and today is actually the birthday, the 1-year birthday of the book. The book has been translated in Spanish and Russian, if there are any people among you who would prefer to read it in Spanish or Russian. A few more logistical details. We have a Twitter hashtag, DDJSchool. If we could have the slide up again, please. Yeah, great. So that's our hashtag. We're going to be tweeting tips and links from this session. We also have, at the suggestion of the participants from last year, we are providing certificates of attendance this year. So if you would like to get one, come to Lucy or me at the end of the session, and we'll write down your name and email address and send you a certificate of attendance after the school is over. I'll now hand over to Gregor to get started with the session.
Hello, and welcome to the workshop called Making Data Visualization a Survival Guide. This is actually a two-part workshop, and the second part is tomorrow, I think, same room and same time. The first part is more about the theory part, and tomorrow I will show like how do you actually use certain tools to produce data visualizations and maps. But some theory first. A few words about me. Again, Gregor Aisch is my name. I come from a more computer science background, so I'm not a journalist per se, but I do work as a freelance interactive news developer and information visualization kind of specialist for certain newsrooms. And yeah, if you're interested, you can check out some of my works at drivenbydata.net, and yeah, that's my Twitter thing. So a few words about the title. I call this a survival guide, and this is because of one of my favorite books. It's called The Worst Case Scenario Survival Handbook, and it holds, as you can see, it holds lots of practical advice to survive everyday situations in life. So my question, I plan to transfer the question to data visualization, and so the question is, as a journalist, how can you produce data visualization, create charts and maps without totally, I don't know, running into the deadly traps that are kind of inherent in data visualizations? So I decided to do this workshop and go through the most dangerous traps and show you why they are deadly and how to avoid them. So this is basically it. And I structured it into 3 parts on charts, color, and maps. And I will, after each section, I will allow you to kind of ask questions, so you don't have to remember the questions to the end. So the first section is on charts. So my first advice for charts is, I will present you lots of examples. This is a chart of a very famous German infographic agency, and it's pretty fancy, and I think it shows the population estimates. So my first advice is to avoid 3D charts at all costs, and the reason why you should avoid 3D charts is that it's simply impossible to actually read the numbers out of them. So you should really use 2D charts. I want to explain this in not only that there are 3D charts are dangerous, but why. So here's an example of a pie chart. It's just a very boring pie chart showing 3 slices. Each of them has the same size, so it should be 33% of kind of visual importance to every slice. But as soon as you make it a 3D pie chart, things are distorting. So the parts that are more in the back are getting less important, and what's more in front. And you can see this in two ways. One is the angel. So we are actually. So I have a cursor. No, there was a cursor. You see this. Actually, pie chart is perceived in 2 ways. One is the angels. So if you actually measure the angels in this pie chart, you have a 130 degree versus 115. So you have the topmost slice is perceived bigger, and the second distortion is in terms of area. So actually, every slice is, if you remove the 3D effect, then this is kind of the area which each of the slices has, and if you actually measure the area in this example, and so you see that it's instead of 1/3 per each slice, now the darkest slice had 50% of the whole area. Yeah, and this is not only used by mistake by by data visualization users, but also by some really used this effect to distort numbers. This is a very famous example of a misused pie chart by Steve Jobs, and so the chart shows market share of different smartphone providers, and so the green one is Apple, and if you compare the green to the violet other slice, and it looks like really bigger, although it's smaller. And I did the same computation for this chart, so I reconstructed it, and so if you measure the area, then you have a ratio of 31% versus 13%, and so if you would just rotate the chart, now the other slice is on the bottom, and so it's a totally different perception. So there's no way to ever use 3D charts in a meaningful way. So next chart I'm going to talk about is pie charts. Pie charts are really unfamous in the database world. Some people actually say you never should use pie charts, and some say you should use them, but you should. And I'm one of the other party. I say use them with care. So they are tricky. The most important advice I can give is that you should limit the number of slices. So actually the ideal number of slices in a pie chart is 2, because the whole idea of a pie chart is to show the relation between a part of the entireness and the whole, so the part of whole relationship. And this is perfectly done in a pie chart with 2 slices. But yeah, you can increase it to like 5, but not use more than 5, because we are not able to get this information. Yeah, and as I said, you should only use the pie charts to show part of whole relationships. So here's an example. One pie chart is showing sales per year, and the other one is showing sales per product. And so there's the one sales per year is pretty meaningless, because there might be sales before 2007 and there are sales after 2012, and so it's not the entireness of the sales. So the whole idea of having a pie chart with slices is meaningless. But on the other hand, the sales per product, if under the condition that this company or whatever is shown has only these 3 segments, then that's a valid use of a pie chart. And yeah, but you should only use the pie chart if you want to show the relationships between parts and the whole. If you want to compare values, you should use a bar chart. And this is because our visual perception system is not able to do this kind of comparison that is necessary to answer a question like how much higher are the tablet sales compared to the camera sales in this case. So what we would need to do is we would need to in our brain we would need to turn the slice and see how often it was fit in the other slice, and we are not able to do that effectively in our brains. So in a bar chart it's a lot easier to answer the question. So you see that's like more than twice. Yeah, so this is for pie charts. I'm now coming to bar charts, as that was a nice yeah, Überleitung, I don't know the English word. So the most dangerous thing when you're using bar charts is to cut off the y-axis. So you should always extend the bar charts to 0. Here's a simple example of a bar chart, and you see that the scale is going from 100 to 120. So there's actually a lot of data missing in the picture, but the baseline suggests that there is some kind of, that they're all ending there. So, but in fact, this is just, I scaled it down, and this is what's hidden in the data. So you get a totally different impression on the data set if you include this. And so this is also commonly used to kind of lie with data. And it's not a good journalistic practice to do this. So in bar charts, always extend the y-axis to the zero. Yeah, here's another tip. It makes bar charts a lot easier to read if you order the bars by value. So, for instance, in this chart, it takes a little time to say like, oh, is B or F, which of them is greater? So the grid lines help a little bit, but you make it a lot easier if you just order them by size. So, yeah, that's a kind of advice. Yeah, now coming to line charts. And the most common use of line charts is to show time series data. So if you have any time series data, which is like the example I shown before, sales per year or population evolution over time or anything that's changing over time, you should probably consider using a line chart. Here's a very famous visualization that is the author, which is Florence Nightingale. It's a pretty old chart, I guess you know it. She used this kind of wedge. I think it's called a wedge chart, but she used this to display as time series. So if you actually try to read this, you see. I really need a cursor. There's a cursor. So the whole data starts here. So surprisingly not here, but on the right side. So this is April, May, June. So and then it goes through the year, and then in March she switches to this side, and she proceeds in April, May, and this is the second year. So she's showing 2 years of data. The data is about causes of mortality, of death in the Crimean War. So, but I would suggest to use this to show this kind of data in a line chart. And actually, the line I looked it up. The line chart was invented 60 years before this graphic. So she could have known. So this is the same data, ranging from 1854 to 1856, and yeah. So the first line shows you the number of wounded soldiers in the war. So alone from this data, you can see which is kind of the action time in the Crimean War. And if you now show the second data set, which is the preventable, this is death by preventable disease, such as yeah, all kinds of illnesses happening in to the soldiers in the Crimean War. You see that there actually have been thousands of deaths even before the first killing took action. So before the war break out, really, and this was a real problem because the British and the French armies was sent over to the region, and they started dying before even firing the first gun, or like, yeah. Yeah, there's also the other deaths. So I think you can tell the story using a line chart pretty good. Yeah, there's another chart that is from time to time used to display a time series. That is a stacked area chart. So what I would recommend to really beware of stacked area charts. You should probably not use them. And yeah, here's an example. It is here's the website where I picked this up. This is a typical example for a stacked area chart. We can, for instance, say these are 3 companies and market share again. So we have company orange, green, and blue. So and now let's, for the moment, concentrate on the company green. And what would you think how the market share of the green company has evolved over time? the graphic kind of suggests that it's getting thinner and thinner. But if you switch green and blue, you see that it's actually increasing. It's constantly increasing market share, but you cannot see this in this graphic. And the reason is that what we see in the chart, so what we actually perceive is this thickness of the area, but what we plot, so the actual data, is this thickness, and we're not able to do this twist in our head. So yeah, so that's probably the reason you shouldn't use stacked area charts. What's an alternative? You could use stacked bar charts, which at least you get rid of the misperception of green. So now you do not get the impression that green is getting smaller, but still it's really difficult to actually compare green or to see the evolution. So again, it's the time series data. It's quarterly market share. Use a line chart. So. And it's just a line chart of the 3 individual market shares, and you can see that green is increasing, blue is increasing, and orange is losing most of their market share to blue. Yeah. So that's a repetition. Use line charts to show time series data. Yeah. Here's this is not actually, the next is not actually a dangerous trap, but it's really helping your readers to read the chart. You should prefer direct labeling wherever possible. So direct labeling means that instead of having the chart on one position and having a legend on the other position, you should, when it's possible, you should consider labeling the elements of your chart directly, so the reader does not need to look it up in some different location. These kinds of steps take time, and so you want to minimize the time it takes the reader to understand the chart. Yeah, and there's one advice. I think it's the last advice for charts. Actually, it's pretty obvious. Label your axis, because if you don't label the axis, then you cannot read the chart. But I found this example very recently. It's a German newspaper, and they published a really huge data journalism application showing all kinds of statistics about Europe. And so the major visualization was a map, but they also provided a kind of statistical view where they had this, you click this green button and then you get to a line chart showing the evolution of, in this case, unemployment. Yeah, but they completely forgot to label the axis. So it's kind of meaningless. You see that something is increasing, but you have to actually look up the text and on top to see the unit of the numbers and to see kind of figure out the minimum and maximum values. So, yeah. Here's a nice thing I read in one of the books. At the end I will present you a list of books that I recommend. And so I found one nice tip in one of the books. By Jean-Luc Dumont, and he's mentioned that it's kind of silly if you have a chart like this you're actually showing 3 numbers, but you're presenting 5 numbers in the grid. So you're making it harder to get the numbers, because now you need to figure out, okay, the cameras is just below 10, maybe it's 9, maybe it's 8 point, I don't know. So instead of using this, you could also use the grid lines here, so you would actually see the 3 numbers. Because there's no need to interpolate if you have just 3 numbers. And you could also label it directly in this case, so that makes it a lot easier to read. And that's about it for charts. I have one more thing on charts, and this is it's not actually about visualization only, but you should always tell your readers why they should care about the graphic. It's pretty well known that if you write an article, you really need to care about the title of the article, and there's lots of brain power going into that. But a lot of visualizations or charts, you see like very silly titles such as, okay, unemployment rate. So I picked an example, a very fairly recent one for the election of the new pope. And I will show you two maps. One is published by The Guardian, on the other is published by New York Times. And both maps show the same data. So it's the distribution of the Catholic population across the world. And there's also a comparison involved between the data in 1910 or 1900 in this case, and the current data. So you see how it changed. So what's interesting about this example is the title each of the publishers picked. And so The Guardian went for the title World Map of Catholic Population. And it answers only one of two important questions that everyone has when I show the questions. The New York Times picked a different title, which is The Catholic Church Has Shifted Southwards Over the Past Century. So the two questions that every reader has when he's looking at a graphic. The first is, what am I looking at? So in this case, a world map of Catholic Church is the answer to the questions. Or if you have a chart of unemployment rates is the answer. But the second question, which is, I would say, equally important, is why are you showing this to me? So why should I care about the graphic? What has this to do with me? So you should always try to answer the second question as well in the title. Here's an example of an unemployment chart, and yeah, we can go through a couple of titles. So this would be maybe the first choice of a lot of people. This youth unemployment rates in Europe. So you know what's shown, but you do not really show why should the reader look at an unemployment chart. So you could also say that youth unemployment is on an historical high, or it depends on the actual story. The graphic is most of the time the graphic is embedded into some kind of story or article. So it depends on the twist of the story. But you could also say that the youth unemployment kind of divides Europe. If you look at Germany and compare it to Greece and Spain. But one thing to remember is there's also this first question: what are you showing? What am I looking at? So you can answer this in a kind of in the byline or in a subtitle. So seasonally adjusted unemployment rates of under 25 age. So yeah, I think it's a valuable advice, and a lot of graphics can be improved by just picking a different title. So that is it for the first section on charts. Yeah, so if there are any questions, you're free to ask them now, or yeah, maybe it's easier than remembering them. I'll take this.
Are there any questions? You'll get another 2 chances, but we thought it would be good to break this down a bit.
It seems to me that with the use of infographics, we tend to forget all these rules.
Yeah.
So you confirm?
Not sure if I get the question right. Who's forgetting it? Sorry.
I mean, when we use infographics,
Yeah.
We tend to focus on visual impact, originality,
Yeah.
and very often we forget. I mean, we as a market, as a fashion also, and the newspaper business, in the media business.
I think this is what separates the good infographics from the one that have some certain problems. So even though they might be pretty, yeah. So.
Any other questions, or shall we let one more in the middle? I'm not sure how I'm going to get to you because there's quite a lot of people. Give me a sec.
Just a comment on the Florence Nightingale data you showed before. And I have a problem because I'm quite a pain in the ass about these things, but you wrote that the data you were showing is the total deaths of the Crimean War, but it's not true, because the Crimean War went on the 53 to the 56, and the Florence Nightingale data is only from the 54 to the 55th. So it's very important when you point out that the data you are showing is a part, a slice of the world you're showing. That was just a comment on, to be clear.
Yeah, I just picked the same data that Nightingale used for this example, but yeah, this is like with what I mentioned in the slide and the pie charts. If the graphic anyhow suggests that you show the entire data set, so this is the remark, you should make sure that it really is the entireness of the data. So if there's anything missing, you should say that it's missing. Yeah. Okay.
Può rimettere il grafico di prima?
I need to pull this on. I'm not. Sorry.
Sì.
Oh, it's pretty quiet.
Allora, questo grafico, mancano i riferimenti sotto, sulla linea sotto, mancano dei riferimenti, non c'è scritto se sono gli anni, sono i mesi. Questo grafico non si legge, è quasi illeggibile. Quello lì che sta...
No, I don't hear anything.
You're missing an x-axis on this graphic. You don't tell us.
Yes. This is for just for this thing.
Sì, poi quando ha detto che è stato messo per stagionale, ma che vuol dire?
Yeah. This is from 1983 to now. So the most recent numbers are from March, I think. Yeah, I'm missing that in this.
Sì,
I cut it off.
Scusi, e la seconda cosa, che abbiamo tante possibilità di grafico, no? Anche molto fantasiose. Se quello non lo facciamo perché dà un'impressione sbagliata, quell'altro non lo facciamo per un altro motivo, alla fine queste statistiche vengono visualizzate tutte in una maniera troppo semplice, troppo anche un po' noiosa. Bisogna trovare qualcosa sempre di creativo per fare vedere i dati.
He's asking if the fact that
you need to find some creative way of showing the data as well, because otherwise if you eliminate one because it can distort things and another for another reason, you're going to end up with just a few ways of showing graphics and it's going to be really boring. So you've got to find creative.
Are all of the windows open?
Yeah.
Because it's very warm
so
in here.
I can repeat the question. This is a good question. Some folks in Dataviz always suggest to use bar charts and like line charts, and so the question was, not a real question, but that we also need to find creative ways to show data, and so if you limit the number of charts or options, then you might end up with the same graphic as everybody. So you need some way to express creativity as well, and yes, this is true. So this is a kind of advice to. They shouldn't be taken too strict. So it's kind of, you should start. I would say you should always start with for instance, the time series. You should start with a line chart, and you can explore from there. But if you never started from there, you maybe missing the main point. So, yeah, and if you look at my personal work, you see lots of different ways to visualize stuff, and that's okay. But you should get the basics first, and then you can develop from there. So, I think that's just for the question for now. We can ask question later too. The second part is on color, and yeah, I decided to make a whole entire section about color because it's a very difficult topic in visualization, and you could do a lot of things wrong with color. And so my first advice, general advice in color, is you should use color sparingly. So try to use as few colors as possible. If possible, try to limit yourself to like 2 colors. You can, as I suggested in this background, you can, with 2 colors, you can easily show some data and have some kind of importance or a second level of attention for the readers. So you can allow some part of your visualization to stand out, and it's not possible if you're using like 6, 7 colors. Also, this is related to the direct labeling. These pretty colored line charts or pie charts or whatever, these color come from a they were needed when you have a legend. So you need to find which part of the legend is labeling what part of the graphic. So as soon as you move to a direct labeling, you can get rid of colors or use colors that are not necessarily be distinguishable. So you can go for one color tone and make it, it looks prettier, and you can use kind of the main color of your newspaper brand, or usually there's some kind of style guide involved, and this point I wanted to take a short break and show some kind of an example chart and trying to fixing it step by step. So here's a ugly pie chart showing sales per product, and again there's just arbitrary data. So the first thing is I mentioned it for the pie chart, for the bar chart, but it's true in pie charts as well, that you should order the visual elements by their size or by their value. So the first thing I ordered the slices. Then there's the rule of you should not show more than 5 slices. So in this case, we could easily combine the 5 small slices. We can combine them into one and name it the other slice. Then we can go for direct labeling. So we don't need the legend anymore, and you can easily pick. We can also label the values to make it even easier to read. And then there's this title. This is kind of the first iteration titles, but you can say this story is about smartphones, and so smartphones are the most sold items. So we can say smartphones still kicking sales or whatever title. But it should focus on the story and not only on the data. Then you can get rid of the colors and use just one color and use line with. So now we need black lines to separate the slices, and then you can use the color to really focus the visualization on what part of the story. In this case, it's a smartphone. So and this is just a few steps, and it's not that hard to do them once you have like the idea of these guidelines. But if you compare it to kind of, this is what comes out if you just make it like in Excel and click on pie chart, but with a few thoughts you can iterate to this. And so now I proceed on colors. Colors is really a difficult topic, and I try to explain this as easy as I can. So one important guideline is that you should avoid pure color gradients. The most common example is the rainbow color scale, which is really used quite a lot in like the scientific maps and all kinds of stuff. And the problem with with rainbow color scale is that there's no inherent order in these colors. So if you take I just picked a few colors of the rainbow color scale, and you would maybe sort them randomly, and you would ask people place them in an order, they would come up with totally different ideas. Because there's no thing that red is bigger than green or something. So even though maybe scientists would use some kind of theoretic concepts of wavelengths to do this, but that's not common. The second problem with is just using color gradients is that it's not a real color gradient. So to explain this, what I mean by color is the hue of the color. So if it's red and blue on white there or green, but there's also additional components depending on the color space. But at least there's one additional component. This is the brightness of the color, and so this is not a pure color gradient because you see that, for instance, the yellow part looks a bit brighter than the blue, for instance. So if I turn this into grayscale, you see this gradient, which is not going from like one value to another, but you have several breaks, and so you really you distort the perception of the value. So if you decide for a color scale in a map or something, a good advice is to vary the brightness of the color and not the color itself. You could do, if you go for more looking for more creative ways, or for some data sets it might be helpful to have some kind of color information as well. You could do a combination of brightness gradient and color gradient. Yeah, but that's yeah, it's important to know. The next advice for color is that you should you should respect the colorblind. I tell this quite a lot, and so you know that kind of 6% of male population are affected by color blindness, and so if I show you this image, probably 6% of the males in the room are not able to see this animal. So hands up, who's not seeing an animal here? So we have 1, 2, 3, 4, 5. So for I had this in other talks, and people were really disappointed if I do not show the actual animal. So I made another slide. So it's a duck hidden there. So it's not just something that's happening somewhere else, but it's actually a huge part of the readership, of the readers that are having this problem. And you should, if you're designing in visualization, you should have this in mind. There's a nice tool that I want to recommend you. That is, it's called Color Oracle, and it's a very simple tool. It's free. You can install it for Windows and Mac and like all the systems. And at any point, you can just press a key, and it shows you the screen as if you were colorblind. So if you open a picture like this, cherry tree, and then you press the key, then you see how colorblind people would see this. So and it's really helpful if you're designing visualizations. You can at any point you can just check it, and then I will show you in a minute how you can fix it. So one obvious advice out of color blindness is that you should say goodbye to red-green color scales. So red-green color scales are really famous because, at least in our culture, red has some kind of meaning of bad, and green has some kind of meaning as that it's good, and so you see lots of visualizations that use red-green color scales. This is one example. This is a visualization called the map of the market, and it shows stock values of companies arranged by sector. So you have, for instance, you have the technology sector, and in this sector you have Apple, and presented by this rectangle. And so the size of the rectangle is the actual stock value, and the color represents if it has been gone up or down since, I think, yesterday or something. So 94% of the male readers are seeing this, but the rest is seeing this. And if you look at the color scale at the bottom, over here, and you compare it with a simulation of the color blindness, so the rest of you sees that it's really hard to tell apart the both directions. But you can easily fix this. I just used this image and I changed the colors a little bit, made it more. I took a bit green out of it and put more blue in it, and now the simulation looks like this. So, and if you compare here's just the legends. You see that for the one not colorblind, the change is really small, but even you cannot really perceive it. But the change for for the colorblind is tremendously. So they have some kind of blue, red color scale now, and yeah. So and you can using a tool such as Color Oracle, you can play around with the colors, and you can try to, instead of a red, you should pick a bit more of a violet. Or instead of a green, you should move the green more into blue, so you get away from red and green. So it's a bit sad to see that like the visualizations like this it's still up. It's up for a year, and I don't know how long this piece is in the internet, but it's probably never get fixed. But yeah. In doubt, there's a website called Color Brewer. I think it's colorbrewer2.com, and there you have a collection of color scales, and you can even make a check on colorblind safe, and you get only color scales that are safe for colorblind people. You can check for colors that are print friendly and several stuff, and yeah, and you can grab the color values, copy them, and use them in your map or yeah. So that's it for color. Are any if you have any questions, you can just drop in, and I think I need to slow down a bit.
Just a question to link this charts to the one before about the nuances in the color charts and the rainbow.
Yeah.
I didn't get the point. I mean, avoid to use the rainbow colors, or just it is quite, difficult, or just use them with different nuances. That was the point.
Yeah, the point is to vary the brightness of the colors.
Okay, so take one basic color like blue, for example, and check out if it's fixable with blind people.
Yeah.
Or so.
Yeah.
Okay.
Yeah, for instance, if you want to have a gradient from blue to red, you should take a very bright blue on the one side and a dark red on the other side, and so you vary the brightness. So that's basically the advice.
A question about not this section in particular, but more in general.
Yeah.
I mean, have you thought about the differences between television and, print or web media? Because for data visualization is very different, I think. So, have you analyzed this point? What are your thoughts about?
I never done any data visualization for TV, but I think there are certainly differences to consider. Yeah, but I think the guidelines I'm showing in this workshop, they apply to all of the three media, so they're cross-media guidelines. Yeah, I think that's a bigger issue that's a big question to answer. Like, could be an entire workshop, probably. I'm not prepared for that now. So, okay, yeah. Yeah, I'm just looking at the time. I think we have lots of time at the end. I'm too fast for my slides. I have 120 slides, but not enough. The third section is about maps, so my number one advice for maps. Okay, some of you know me; they know it probably. You should never, under no circumstance, use Mercator projection for world maps. So Mercator projection is this is one. So to explain map projection is the world is a sphere, kind of, and no, it's not. But if you want to show an image of the surface of a sphere, you need to project it in some way, because an image is not a sphere, it's not three-dimensional. So there's different projection methods to use this, and the Mercator projection is one that's commonly used in certain web-based mapping applications, such as Google Maps or any other kind of tile-based map servers. And so you're probably familiar with this kind of image. If you zoom out at Google Maps, you see this huge Greenland, and compared to Africa, it's really, they look like equally sized. And but if you look at a different projection, this is a orthographic projection, which is just like if you were looking at a globe, you see that there's a huge difference between the size of Greenland and the size of Africa. And so there's one big criticism point of the Mercator projection is that it's in general it makes Africa and lots of the kind of developing world look comparably small compared to like of the Western world and Australia. So there's one really famous infographic named "The True Size of Africa," made by Kai Krause, and he has compared the size of Africa to countries in the world, and actually he managed to fit China, United States, and like Spain, France, Germany, Italy, India, UK, all these together are as big as Africa, and so. But this, you get a totally different impression if you're looking at a Mercator world map, and yeah, there's a really sad thing happening for especially if you're living in Greenland. A lot of people, map makers, are concerned about the hugeness of Greenland. And they think they're clever, and they just let Greenland magically disappear from the map and think, okay, it's fixed. I can really show you examples, and I'm collecting them for a while. So some people really think that omitting Greenland will fix the Mercator map, but it's not. So what you can do? So if you're designing a world map for publication or anything, you should consider using an equal area projection. So an equal area projection is, this is one example. It shows you the countries of the world in their true size. So you can take any country and compare it to any other country in the map. So that's called an equal area projection. There are lots of beautiful maps that use equal area projection. So, and it's a kind of being politically correct or so, or use different, but not use Mercator. But Mercator is one of the worst. And to prove this, I will show you a web comic by a very famous comic drawer, Randall Monroe, and he compiled this lovely comic strip by showing you what your favorite map projection says about you. So the idea is that there's some kind of mindset inherited in every map projection, and so, and for Mercator projection, he said, like, you're not really into maps. So, and yeah, here's a link, and you can look at it yourself. But so here's, for instance, one map projection, the Robinson projection, which at least takes a bit care about the size, but there are other projections, and so this is a good point to start research about map projection text actually. Yeah, so there are, you see on the right, there are some really really fancy map projections like Waterman Butterfly, and yeah. So, and actually this is, I think this is almost my last advice for this workshop, so we have lots of time to work. Is if you're presenting symbols on a map, you should size them by area, not by radius. And I took some slides to explain this because it's maybe not really obvious. I found an example for this in an infographic magazine, in German one, and it's showing the Tour de France locations over the last 100 years. So this is a very common example for like circles on a map, and they made this mistake. That's why I picked the example to scale the circles by radius. So I'm gonna explain this step by step. So let's start with 5 numbers. 1, 2, 3, 4, 5. And now you pick. I add lines for each number, and so then the length of the lines is proportional to the numbers. And if you would use these lines as a radius for a circle, you get these 5 circles. So I just name them 1, 2, 3, 4, 5 to remind us what they represent. And if you just compare 1 to 5. It might look okay in the first look, but if you really try to fit in the 1s in the 5, you see there's lots more space. To explain this, I'm going to show you a little math. I'm not sure when it was yet last time you saw math formulas, but this is the formula for the area of a circle, and it's the area is the product of pi times the radius to the square. So if you have a circle with a radius of 1, then the area is just pi. So we have 1 to the square is 1, and times pi is pi. Now we're looking at the bigger circle with a 5, you see it's pi times 5 to the square. So 5 times 5 is 25. And so the area is 25 times p. So if you take them side by side, you see that the one is 25 as big as, the 5 is 25 as big as the pi, as the 1. So if we want to actually have an equal measure, so equal size, we would need 25 of those small 1 circles. So now the tricky question is, what are we going to do to have an equal relationship between 5 1s and the 1 to 5 circle? And some of you probably know the answer. We have plenty of time. I can make this a quiz. So who knows the answer?
You use squares instead of circles? I don't know.
Squares instead of circles? Okay, this is interesting. But you would run into the same problems. So this is why I said it's like every symbol is involved, because for a square we wouldn't have the pi, but it's still the two sides are multiplied, so we still have this problem.
Numbers alone?
What?
Numbers alone, I think he said.
The numbers alone. So you suggest to just not use the circle at all? Or yeah, that's an idea, but this would move away from the actual data visualization. So
you just put the area 5 times the other area and find the radius.
Yeah, that's interesting. So I will show you how to do it. It's very simple. There's a kind of inverse operation to the square. It's called the square root. So you may have seen the sign, yeah. So what you need to do is you just take the value you wanted to show on a circle and take the square root of it and use this as a radius. And then you have an area that is proportional to this. So in this case, the square root of 5 is 2.2 something, and if you use this as a radius, you get a circle in this. So I show you these 5 circles again, and so the correct version looks this. Yeah, so just take the radius and then the square root, and then you're safe. So I recreated the map of this magazine. So this is the original map, and it's after a while you get really I get a kind of sense for maps that are where the map makers have forgotten to take the radius. So you have the bigger the values, you get this huge circle somewhere, and there lots of tiny sphere. So the same data set with square roots looks like this, and this is the actual representation. So it's not just a tiny fix, but sometimes it's an entirely different image. And yeah, so you should always take the radius. Here's another example. I've showed you this before. Florence Nightingale also used the absolute numbers as radius for each of these slices or wedges. Yeah, I fixed this. There's an online version. I just used an online version of it. And you can, if you see the same graphic with radius, so this is the actual representation of this data set. So yeah, that's pretty much it for this session. I can show you some I would recommend 2 books. So the one is really recommended by Dana Wong. She's used to be the graphics director for the Wall Street Journal for quite a while, and she has written a really lovely book that is called The Wall Street Journal Guide to Information Graphics. And yeah, I really recommend to just get a copy of it. It shows lots of these examples I showed you, and you always have the right side and the left side in the book. One side is showing how you better not do this stuff, and the other side is showing you how you should improve it. And yeah, the other book is by Jean-Luc Dumont, and I think I got the name right. And it's called Trees, Maps, and Theorems, and it's a book about communication, but it covers a lot of the issues, and some of the advice I mentioned here I took from this book, and I think it's a really clever book, and I would consider him to be like the Edward Tufte of Belgium or Europe, maybe, I don't know. It's a really thoughtful book. So, and there's the ProPublica News App Style Guide. You found it on GitHub. All the links are included in the material. So, yeah. It's also a good place. Yeah, now we can spend some time on questioning, or if you have anything. Yeah, I'm open for questions now. Thank you.
So given the fact that we can see one-dimensional differences easier than two-dimensional differences or even three-dimensional differences, would you suggest to break down the dimensions if we want to compare bare numbers? Like I can easier tell if a line is twice the length than I can tell if a square is twice the size or twice the area, or a cube is twice the volume.
The choice really depends on the what you're wanting to achieve with the graphic. So if it's about comparing values, so answering questions like how is this twice as big as this or something, then you should indeed try to use one-dimensional, like line length or probably line length or position of elements in a scatter plot or something. While if you want to show like the distribution of values, it's okay to use size symbols. Maybe it's easier. So because you have the two dimensions for the position, you can use them for like showing the geographic position or any other kind of axis. So yeah.
Yes. My question is, I don't know if you have statistics about this, but out of, let's say, 10 charts you find in the media, how many suit your recommendations and how many don't?
I don't have any data on this, but my feeling is this is getting better and better. So I think... So my work mainly focuses on online, and in online you see some kind of lots of graphic teams doing maybe their first steps, their first graphics, and so this is maybe a bit distorted, but I think usually in printed graphics these guidelines are common. So yeah. Hi.
Do you have any other program, any software to suggest to create infographics or similar?
I need to mention tomorrow at the same time I will do this workshop where I recommend tools and actually show some of the tools, and you can there's also a kind of tutorial I provide for every tool, so you can do this at home again, or you can try to do it while I'm doing this. So tomorrow is on the practical side of things.
Thank you.
You're welcome.
Oh. Any other questions?
I just wanted to ask, since you started out by saying that you're not exactly a journalist, you came to this from a different side. So I'd really love to hear about what configurations of teams, of professionals working in teams, you find the most useful and productive in creating something like this? Because obviously there's got to be input from so many people. You know, you need to work with the reporter, with the editor on what they want to say, on what's the emphasis in a particular story. If you could describe that process, that'd be great.
I think it's very helpful to have some team, some guys from the, if there's a graphics department in the newsroom, try to get one of these guys or girls to help. There's different types of graphics. So some are really small, like pieces you would finish within half of a day or a day. So I think those kind of graphics should. There are more and more tools that allow like every journalist to produce this kind of graphics, like this line charts. But on the other hand, if you have like complex maps or anything, that might be necessary to bring up more power. So yeah, there's a lot of people ask whether or not journalists need to learn to code. But I think the tools are really catching up and making it easier and easier to for everyone to create tools. And yeah, I'm working on a project called Data Wrapper that I wanted to show you tomorrow too. And this is a tool where we try to implement some of these guidelines in the code so that you don't need to worry about it. So this is kind of an idea to help journalists or other people publishing information on the internet or to get this done. So things are changing. So yeah.
In what case would you need a developer to work on the project?
So I think as soon as it gets interactive. So if you want to have a graphic where you can click on something to filter or to change the perspective or anything, then you should probably have someone in your team who has done this before, or because as soon as it gets interactive, you have lots of things to consider, like performance and it should work in different, like on tablets and on different browsers, and so this is really tricky. And if you're doing this the first time and learning this by some kind, that's really like that I would suggest to get some kind of help by. But often you find that there's even developers in newsrooms that are not really working on graphics, but they could maybe provide some help. So there's always like teams working on the website, and they know more about different browsers than any journalist working on graphics. So maybe it's a good idea to try to bring these people together. Okay.
I've got a question, Gregor. Given you've just mentioned visualizations for tablets, are there any other pieces of advice you would give people for making visualizations specifically for tablets and phones?
Yeah, that's a bit like the other question, the cross-media thing. So obviously, if you have devices such a phone, you need to limit the number of elements that you show, because of the performance of the phones, but also the screen size is very important. So on a full screen web page, you can show a lot more stuff. For tablets, you have this different interaction models. So you do not have a mouse and keyboards, but you touch on anything. So you could do fancy multi-touch stuff if you like. So there's lots of differences in the devices.
Excellent.
Okay.
Are there any more questions? Does anybody have any other questions? If not, could everybody just join with me and thank Gregor very much for the talk. Thank you, Gregor. That was fantastic. And just to remind you that the second version, the hands-on version, will be tomorrow at 2:00. Hopefully not as warm as this one, because this one was very warm, but just as exciting. So if anybody would like a certificate of attendance for this session, please come and see Liliana and I down here in the corner, and hope to see you tomorrow at the same time. Thank you.
I don't know actually where, maybe on this one.
There you go. That's that.
There's and then
click present.
Where's present?
There we go.
Cool.
That works. That's awesome.
So you want to say something?
Lily, do you want to start this one? I always start. You start. Welcome, hello everybody, and welcome to the third workshop of the School of Data Journalism, second edition in Perugia. We're really, really happy to have Gregor Aisch with us, and I'm sure that you're probably as excited as we are about it. Just a couple of words about the School of Data Journalism and about how it's organised before we start. We're very grateful to the organisers of the International Journalism Festival for letting us organise it. It's a collaboration between two organisations. My name is Lucy Chambers, and I work for the Open Knowledge Foundation, currently in Berlin. We work both with governments and with kind of civil society organisations like.
The center has been organising a lot of training activities in data journalism over the past 2 years. We have a website called datadrivenjournalism.net where you can find learning resources about this topic. We also published a manual last year together with the Open Knowledge Foundation called the Data Journalism Handbook, which is freely available online at datajournalismhandbook.org. And today is actually the birthday, the 1-year birthday of the book. The book has been translated in Spanish and Russian. If there are any people among you who would prefer to read it in Spanish or Russian. A few more logistical details. We have a Twitter hashtag, DDJSchool. If we could have the slide up again, please. Yeah, great. So that's our hashtag. We're going to be tweeting tips and links from this session. We also have, at the suggestion of the participants from last year, we are providing certificates of attendance this year. So if you would like to get one, come to Lucy or me at the end of the session, and we'll write down your name and email address and send you a certificate of attendance after the school is over. I'll now hand over to Gregor to get started with the session.
Hello, and welcome to the workshop called Making Data Visualization a Survival Guide. This is actually a two-part workshop, and the second part is tomorrow, I think, same room and same time. The first part is more about the theory part, and tomorrow I will show how do you actually use certain tools to produce data visualizations and maps? But some theory first. A few words about me. Again, Gregor Aisch is my name. I come from a more computer science background, so I'm not a journalist per se. But I do work as a freelance interactive news developer and information visualization kind of specialist for certain newsrooms. And yeah, if you're interested, you can check out some of my works at drivenbydata.net, and yeah, that's my Twitter thing. So a few words about the title. I called this a survival guide, and this is because of one of my favorite books. It's called The Worst Case Scenario Survival Handbook, and it holds, as you can see, it holds lots of practical advice to survive everyday situations in life. So my question, I plan to transfer the question to data visualization, and so the question is, as a journalist, how can you produce data visualization, create charts and maps without totally, I don't know, running into the deadly traps that are kind of inherent in data visualizations? So I decided to do this workshop and go through the most dangerous traps and show you why they are deadly and how to avoid them. So this is basically it. And I structured it into 3 parts.
Journalists and NGOs, both to open up access to information and to work with people who need to use that information once it's been put out in the public so that they can use it. And I work particularly on a project called the School of Data, which I think is confusing people a lot because this is a School of Data Journalism. But there are 2 organisations involved in the School of Data Journalism. The second organisation I will hand over to Liliana to tell you about, but the European Journalism Centre has been our partners in organising this, and Liliana runs the datadrivenjournalism.net website. All of the tutorials and things that you see here, both schoolofdata.org and datadrivenjournalism.net are going to publish straight after the workshops, so don't worry about taking notes all the way through this. You can give Gregor your undivided attention, and he will guide you through the process. But over to Liliana now.
Hello everyone, I'm pleased to see so many of you here today. Data visualization is a very popular topic these days. I am Liliana Bounegru. I lead data journalism activities at the European Journalism Centre.